Suppose there be a function y equal to fx. It may be in any form. You can take y equal to x cube. This is a function of x. You can take y equal to e to the power x, y equal to log x. All these are functions, their graph can be plotted in their domain of definition. Now, here we want to find the rate of change of y with respect to x. Y is dependent variable, x is independent variable here. Or x stands for the domain of the function and y is the range. To find the rate of change of y with respect to x, in applied mathematics in class 11 syllabus, we must remember that formula 1 where I will be telling you derivative of x to the power n. This is n x to the power n minus 1. I mean, how x to the power n changes with respect to x, this is given by this formula. This ddx stands for what? ddx stands for the operator. This means rate of change of. So, x to the power n changes with respect to x by this formula. For example, if the function is what we have taken there, y equal to x cube, its rate of change of the function y with respect to x will be what? That we can write ddx of y. This is equal to ddx of x cube. So dy by dx going to be 3x to the power 3 minus 1. Okay. So if y equal to x cube function is there, then its rate of change of the function y equal to x cube at an arbitrary point x can have any value 0, 1, 2, 3, minus 1, whatever. We can get the rate of change of y with respect to x by using this formula. Then another example, what is rate of change of x? This is nothing but ddx of everything we will get by formula only. This is 1 x to the power 1 minus 1, 1 into x to the power 0, that is 1. Okay. Now all these we get by using first principle of differentiation. Right now it is excluded from your syllabus. You can see one of the video I made earlier where derivative of y with respect to x can be determined by using first principle of differentiation. In fact, the formula I will be sharing with you here depend on the first principle of differentiation. Okay. So this formula derived from there. Right now we will be applying all these things not required for your school based examinations. Even for any entrance examination also, concept of first principle is there, but how to find derivative by using first principle, that is not required. Okay. So formula 1 and we have applied in two sums, and you can memorize this part. ddx of x will be 1. ddx of x cube is 3x square. Any function you can find which is exponent of x by this rule. Suppose somebody asked you to find what is the derivative of, say, 1 by x to the power 9. How do you find? You will say that this formula is there. It is rate of change of x to the power minus 9. So use the formula minus 9 x to the power minus 9 minus 1. So minus 9 by x to the power 10. You can write ddx of 1 by x to the power 9 equal to minus 9 by x to the power 10. What is the derivative of root x? ddx of root x. Can you find it so easily? Yes, because we will be using the same formula. ddx of x to the power n is nx to the power n minus 1. This is ddx of x to the power half x to the power half minus 1. So answer is 1 by 2 root x. Okay. So derivative of any exponent of x can be determined by using the formula which we have got, ddx of x to the power n equal to n x to the power n minus 1. That n may be any real number. It may not be the integer always, maybe negative integer, maybe fraction. In all cases this formula is valid, and that we have applied. X to the power half is a fraction here. So we found derivative when index is a fraction also. Now let us know the formula where log is involved. Number 2 formula we learn this manner. If y equal to, you can write this here also. If y equal to log x, then dy by dx is 1 by x. That is, rate of change of log x with respect to x will be 1 by x. Alright. Right now I am not discussing any example log, but we will be doing many examples based on it. Now let the third formula, that y equal to a to the power x. Then by formula dy by dx, rate of change of y with respect to x will be a to the power x log a base e. Okay. So let us apply it in solving one very simple problem, that y equal to say 5 to the power x is there. So dy by dx going to be what? This is going to be 5 to the power x log 5. Even I am not writing any base over there, it indicates that base is e. At your standard, log means log of anything, no base is mentioned, that base must be e. That is, it must be a natural logarithm. So this is third formula and one simple application we found. Let us say another example here. This is example 1. Taking example 2 here, say y equal to 1 by 2 to the power x. Can I use this formula here? Yes. If we write it in this manner, half to the power x. Same thing. 1 to the power anything is 1. So y is half to the power x. Now differentiating with respect to x. dy by dx will be equal to, a is half only, so half to the power x log half. This is derivative of y with respect to x. You can simplify it as 1 by 2 to the power x log half. It's up to you whether you will simplify or not. Now there is number 4, that let y equal to e to the power x. E you have learned as base of logarithm, its approximate value equal to 2.74. So when you write derivative, I mean ddx of e to the power x, then it will be e to the power x only. Okay. Or you can write, if y equal to e to the power x, then dy by dx is also e to the power x. So e to the power x is also done. Now the last one, at this moment going to be derivative of a constant function. Constant can also be a function. If y equal to constant, what is the rate of change of y with respect to x? If y is a constant, that constant value can never change. So its rate of change of going to be equal to 0. Then dy by dx will be 0. Let y equal to c, then dy by dx must be 0. Or ddx of c is equal to 0. You can write ddx of 7, that is 0. ddx of 10 to the power 10, this is also a constant, that is 0. Any constant, its rate of change of is, that rate of change of that function with respect to x going to be equal to 0. So constant function derivative equal to 0. Now by knowing this set of 5 formula, I just remind you, number 1 was ddx of x to the power n, it is nx to the power n minus 1. Formula number 2, it is ddx of log x equal to 1 by x. Formula number 3, learn it by heart, ddx of a to the power x. This is going to be a to the power x log a base c. Then formula number 4, ddx of e to the power x is e to the power x only. And number 5, ddx of a constant equal to 0. These 5 formula I am telling you repeatedly, you only need in class 11 and 12. No other formula is required. Then you can tell me how to differentiate root 1 plus x square, how to differentiate log of 5x square plus 7x minus 9, or say x square plus 3 to the power x is there, how to differentiate it, or e to the power x cube minus 7x plus 6 is there, how to find? You must know step by step. All these basic formula when you come to know, you can start the chapter of differentiation and then you can solve it on your own by knowing the rules of differentiation. If we write rule of differentiation, basically there are 3 rules of differentiation: the sum rule, the product rule, and the quotient rule. Sum rule can be restated in another manner that I am telling you. Let us know what will happen if sum of 2 functions are there, the derivative. Derivative of sum of 2 functions fx and gx is given by derivative of fx plus derivative of gx. For example, suppose y equal to x to the power 4 plus log x given, and you are supposed to find the differentiation, dy by dx. So you just write differentiating with respect to x, dy by dx going to be 4x cube plus 1 by x. If it is not clear, you write dy by dx equal to ddx of rate of change of y is rate of change of x4 plus log x. Now use the sum rule. It is rate of change of x4 plus rate of change of log x. Rate of change of x4 is 4x cube and this is 1 by x. So dy by dx is 4x cube plus 1 by x. Similar is the case if there is difference of 2 functions. We can write ddx of fx minus gx as ddx of fx minus ddx of gx. So if there is a function y equal to, say, 1 by x square plus 2 to the power x, let y equal to this, and the question is find dy by dx. Let's see how to find dy by dx from here. No, there will be minus sign, not plus sign. We are going to use this law, so minus. Again you write differentiating with respect to x, dy by dx will be ddx of 1 by x square is x to the power minus 2 minus 2 to the power x this is ddx of x to the power minus 2 minus ddx of 2 to the power x to the power minus 2 is minus 2, x to the power minus 3, 2 to the power x derivative is 2 to the power x log 2. Alright. So derivative of 1 by x square minus 2 to the power x can be determined by this. Now we can state this sum rule in another form also. Suppose there is ddx of a constant k into fx, then k you will take outside, it will be ddx of fx. Okay, so let us take one example based on it. Suppose y equal to 7x cube given. How to find dy by dx? This dy by dx will be ddx of 7x cube, 7 will come out, so 7 into 3x square, this is 21x square. What I did there, this is a constant, here 7 is also a constant, so I took 7 outside and then differentiated by ordinary rule of differentiation. 7 outside, ddx of x to the power n formula I have used, so it is 7 into 3x square. Now let us see how these two rules can be combined, the sum rule or difference rule and this constant one. Like let y equal to 3x square minus 7x plus 6 is there. And another thing you should remember, the sum rule whatever you have used, it can be extended for more than 2 functions also. If there are 3 functions or 4 or 5, whatever, you can extend it. The derivative rule you can extend for the sum of these 3 functions, it may be sum of n functions, whatever. It will be derivative of hx. Okay? So when you are going to find dy by dx for this function, you just write differentiating with respect to x, dy by dx will be ddx of 3x square. So how many functions are there? That you can see sum of 3 functions. So you write ddx of 3x square minus ddx of 7x. So the value is 3 will come outside. Ddx of x square, 7 will come outside. Ddx of x, and what about the third one? It is constant, its derivative going to be equal to 0. So this one now, if you simplify, it will be 2x to the power 2 minus 1, 1x to the power 1 minus 1. So it is 6x minus 7 is the answer. if there is combination of two or more functions, we can proceed this manner. There may be function like this also. They have asked you to find derivative of, say, y equal to 20 by x to the power 6. Let then find dy by dx. How to do it? You write differentiating with respect to x, dy by dx will be equal to d dx of 20x to the power minus 6. For 20 it is a constant, you can take it outside. X to the power minus 6 differentiation, you can do 20 d dx of x to the power minus 6. 20 minus 6, x to the power minus 7. Okay? This way we can use some rule for differentiation. Now let us go for product rule of differentiation. Let's see how product rule can work. So what is product rule of differentiation? So the product rule of differentiation states that if there be a product of two functions, right now for two functions, can be extended for three or more functions, derivative of product of two functions will be derivative of first into second plus first into derivative of second one. You can change also. If you write this one first, no issue, and second one is this one. So let us apply the product rule. So you will be given two functions. One of them is fx, the other one is gx. Let us take fx equal to x to the power 7 and gx equal to log x. We want to find derivative of this thing, fx into gx, x to the power 7 into log x. So differentiating with respect to x, dy by dx will be what? Derivative of x to the power 7 into log x. This plus x to the power 7, if you have differentiated before, then it's fine. This into, and then you write x to the power 7 into derivative of log x. Rule says that only. Derivative of first fx into gx, log x. You are not differentiating log x here. Then x to the power 7 into derivative of log x. So this is going to be 7x to the power 6 log x. So there will be 7x to the power 6 plus x to the power 6. So product of any two functions given this manner, you can find the derivative by using the product rule. Let us take the second example. This was number 1. Let us take y equal to root x 3 to the power x, product of these two functions. Let us apply the product rule for this. We write y equal to x to the power half into 3 to the power x. So differentiating with respect to x, dy by dx going to be what? The derivative, the way I have written the rule, I told you these two can be interchanged. It is derivative of first, this multiplied by 3 to the power x, x to the power half, d dx of 3 to the power x. fx dx we have distinguished. Now we are going to use the formula. X to the power n, you know, nx to the power n minus 1. So half minus 1, 3 to the power x. 3 to the power x derivative is 3 to the power x log 3. So this is nothing but 3 to the power x by half minus 1 is root half, 3 to the power x by root half, this plus x to the power half, 3 to the power x log 3. You can take 3 to the power x common. If you don't take common, no issue, you will be getting the marks. Alright? So this is product rule. For product of two functions given, you can find dy by dx. Let us go for quotient rule now. The quotient rule of derivative also regarding fx by gx. I mean, there is a quotient fx by gx, we have to find differentiate. Then we have to find derivative of fx by gx. So the rule is gx whole square, gx into derivative of fx minus fx into derivative of gx. So when you are going to use this rule, we will be taking a function like this, y equal to x4 by log x. See, it is taken this manner. So what is dy by dx here? dy by dx will be, see, what is fx, what is gx here? For this problem here, fx is x to the power 4 and gx is log x. So dy by dx will be what? It is log x whole square, log x into derivative of x to the power 4, x to the power 4 derivative of log x. Alright? So this is, what is x to the power 4 derivative? Like x to the power n, nx to the power n minus 1. This into 1 by x by log x whole square. So it is 4x cube log x minus x cube divided by log x whole square. Okay? This is example 1 on quotient rule. Let us take another example on quotient rule. Bit bigger than this, but can be done if this concept is clear and you remember the derivative of the sum of two functions, the product of two functions. Let us find dy by dx, or I mean derivative of this one, x square plus 1 by x square minus 1. By quotient rule, obviously, differentiating with respect to x, dy by dx would be x square minus 1 whole square, x square minus 1 ddx of x square plus 1. Why? Because it is denominator into derivative of numerator minus numerator into derivative of denominator. I remind you, this is the thing, fx by gx. So you are differentiating fx first, this multiplied by gx minus fx into derivative. So derivative of gx. So there will be x square minus 1. Now see, inside quotient rule, it is coming the sum rule. Can come over there. You write this as ddx of x square, the sum rule, ddx of 1 minus x square plus 1 minus ddx of 1. Okay? So that divided by, it is x square minus 1 whole square. So this will be x square minus 1 2x plus 0 minus by x square minus 1 whole square. Now you can simplify this. Numerator you take 2x common, x square minus 1, this by these two get cancelled, minus 4x by x square minus 1 whole square. Okay, so this is the value of dy by dx when there is quotient of two functions.